Okay, so we're going to be talking about dimensional analysis, which is essentially just a math, strategy that we use in chemistry and in science in general to convert units from one thing to another. Okay, now a conversion factor is just going to be a ratio of numbers and units. So a ratio of numbers and units that are equal to each other. So for example, we know that 1 hour is equal to 60 minutes. This is an equality that most of us are very well aware of. Now, this equality can be written as a ratio or conversion factor in two different ways. We can write 1 hour over 60 minutes, but we could equally write 60 minutes over 1 hour. These things are both essentially equal to each other and also equal to 1. Now we know that 1 times 7 is going to be equal to 7. It doesn't change its number. In the same way that if we were to multiply 1 hour divided by 60 minutes times 7, it wouldn't change anything. It would essentially remain the same. So we're going to use these conversion factors in our examples and our problems to really figure out, okay, how can I convert from one unit of measurement to another? So if we look at our first example problem, number 1, it says 346 millimoles to mole. So they want us to convert from millimoles right here into just normal moles. Now remember, milli is a prefix, so if you need to refresh your brain about King Henry died by drinking chocolate milk, okay, the prefix thing, we know that B is our base unit, basically what we start off with that has no prefixes, and the mole would be here. Now, millimoles would fall right here on the ladder. So that tells us that there are 1,000 millimoles is equal to 1 mole. That's what that little acronym or mnemonic device helps us remember. So what we'll start off with is we always start by putting the number that's given to us in the left-hand corner of our work. So 346 millimoles. And then we're going to draw a horizontal line here and a vertical line that will separate it from our conversion factor. So we have what is given to us here, and we're going to write our conversion factor in the next space. Now, we determined our equality earlier, 1,000 millimoles is equal to 1 mole, and that can be written as either 1,000 millimoles over 1 mole, or 1 mole over 1,000 millimoles. They're both equivalent except their units are in different places. So we need to decide what would be the best thing for this particular problem. Now, when you have millimoles here, the goal is to get rid of millimoles and get into or have remaining moles by itself. So in order to do that, in the same way that if you were to have the problem 2 times 3 divided by 2, you could cancel out the 2's because we have one on the top and one on the bottom. We can do the same thing with our units in the problem. So if I want to be able to cancel out millimoles, that means I need millimoles in the bottom, which means I will be using this conversion factor. So I'll put 1,000 millimoles on the bottom and 1 mole on the top. Now we see that my millimoles here cancel out with millimoles, and all I'll have left with at the end is moles, which is perfect because that's what they were asking me for in the problem. Now we say, okay, well, I see that you have these numbers and these units, but what is the actual math? What do I put in my calculator? And the way you're going to do that is you're going to multiply what is on the top and you're going to divide by what's on the bottom. So 346 times 1 is 346, and 346 divided by 1,000 is going to give you 0.346 moles. And that will be our final answer. So let's look at problem number 2. Problem number 2 is a little bit trickier. It gives us 0.35 meters per second, and it wants us to convert that to kilometers per hour. So that means we're going to need to do 2 different conversion factors in the same problem. Now, the reason why we do dimensional analysis is it allows you to put it in your calculator all at one time. So we'll start by putting our 0.35 meters over seconds, essentially saying per 1 second here. And we know that at the end, we want to do kilometers per hour. So we're going to start off first with switching meters into kilometers. Now, if we go back to our King Henry died by drinking chocolate milk help chart, meters is going to be my base unit, and kilometers is going to be right here. So what that means is we know that 1,000 meters are equal to 1 kilometer, and we need to decide which unit will go on the bottom and which one will go on the top. Well, we know that if I have meters in the top, I'm going to need my meters to go on the bottom in order to cancel out. So I'm going to put my 1,000 meters on the bottom and my 1 kilometer at the top. This will allow my units here to cancel out, and I know that I have kilometers, which is what I was trying to get to. So now we know we're in kilometers per second, but I need to go from from seconds to hours. So let's do a second conversion chart. We know that there are 3,600 seconds in 1 hour. So when we do this, we know that we need our seconds to be opposite of where they are currently. So seconds are currently on the bottom, so the opposite of that would be on the top. So we're going to write our 3,600 seconds on the top and our 1 hour on the bottom, and our seconds will cancel out, and we are left with kilometers per hour, which is great. And so now we need to put things in our calculator. So I'm going to take 0.35 times 1 times 3,600 divided by 1,000. We can kind of ignore the ones because ones don't affect anything in math. If you multiply by 1, it's 1. If you divide by 1, it's still 1. It doesn't change the answer at all. So we're going to keep going with this, and we get as our answer, oh man, we get 1.26 kilometers per hour as our final answer, which is great. And that will record or end our video here. If you want to look at these ones down at the bottom, you're going to need to come in for tutoring or things of that nature for now.